three missions heading to Mars. That's the Chinese mission, NASA's, and also the United Arab Emirates with their HOPE project. They're using the window of opportunity to get there. Apparently, if they don't go now, they're going to have to wait another couple of years. And looking into the background for Mars missions, I found a great webinar from Switzerland's Maxon Motor, who have more motors working on Mars than any other company. So we're in touch, and we're joined now by the presenter of that webinar, the head of the Space Lab for Maxon, Robin Phillips. Robin, welcome to the programme. Now just tell me, what's this fascination with Mars? It's going to get pretty crowded up there with three missions going off in 1 month.
I think humans in general have always had a fascination with Mars ever since the ancient astronomers several thousand years ago realized that those 5 bright spots of light that we can see in the sky ourselves that move relative to the other stars, that they're special in some way. Since we've had telescopes and spacecraft able to go there, we've realized that Mars is really the only one where we have a possibility to physically go ourselves. It's not too hot, it's not too cold, no poisonous gas, and it's somewhere we can imagine living ourselves.
So Maxon's been involved in Mars for a while, I think, or certainly on the space side. Tell us a bit about Maxon and what your involvement is in these space projects.
So Maxon is a 60-year-old Swiss company, family-owned, that specializes in building electric motors, gearboxes, and feedback devices. So that's everything that you need to make an actuator to make things move. The majority of what we do is industrial or medical applications. The real interest has been over the last 10 years to pick out applications that help us drive our technology forwards and provide sort of interesting applications that we can then talk about and present outside of the company.
So part of all that, of course, is the Mars Rover project. So Maxon have been involved in those programs. How difficult are the technologies then that you have to do, and what's improved in recent years? I think you're on one of the projects that are going to be going off in July. So what's happened? What's the technology changed?
First of all, you have to ask what's different about flying a motor to Mars and having it operate on Mars compared to having it going into a factory that makes sewing machines or something like that, which would be a sort of standard industrial application. And the big things are shock and vibration when you're on the rocket being launched. So obviously there's lots of vibrations going on there, and the motor mustn't fall apart whilst that's happening. Then it has to be in a condition to survive 6 months in vacuum as it travels to Mars. Then again, we have more shocks and vibration whilst it's coming in through the atmosphere. That's the 7 minutes of terror that you may have seen the video that JPL let out a few years ago. It has to survive that. And then when it's on the surface of Mars, probably the hardest one is the Martian climate, which cycles every day between minus 130 degrees C at night and just above freezing during the day. And these temperature cycles are really hard for materials. And if those materials expand and contract at different rates, if you don't have that perfectly matched, your motor will fall apart after a few hundred cycles. So that's the thing that makes really the biggest engineering difficulty for us. We can show that our designs work for that by having the testing facilities here on Earth, and we have them in the Maxon facility here in Switzerland, where we can take our designs and put them in a climate chamber or environmental chamber and cycle them hundreds of times between the minus 130 degrees and the plus 10. And usually it fails the first time. And then we go back and we tweak the design, we figure out what we did wrong, and then we test it again. And we keep doing this cycle until we have it right. And that's how you end up with a design that then works reliably. If you do all that well, then it can last for 14 years like Opportunity did.
Fantastic.
And we very much hope we've done it well for the upcoming Mars 2020 launch in July, because we have critical application on there where our motors will be gripping every sample that the rover collects to analyze with the goal of bringing them back to Earth in a later mission. And if this arm that our motors are mounted on doesn't move, or the gripper on the end, which is our motor, doesn't work, of course the whole mission is a failure. So we have absolutely critical applications here on these multi-billion-dollar rovers.
Well, if you want to see the webinar that I was talking about that gives you all the background to how Maxon Motors work on those space projects, here's the link there. And if that doesn't work for you, then go to our website, read the story, and there's a link into the YouTube there. So thank you for joining us. Robin, thank you for joining us, and Good luck with that project.